All right, welcome back to Meteorology 101. Just recently we did a surface chart analysis. This is the next day, and we're not going to get too deep into the analysis this time. We will a little bit because you always have to looking at charts, and you got to see where your frontal placements are and your upper air data, and see if you have an upper front, upper level troughs, major short waves. We need to identify those features on these charts, even in the upper levels, to see what kind of support we have for these systems. So I'm going to go ahead and throw the surface pressure on here, and then we're going to see where our low pressure center is. Yesterday it was right over around Arkansas, Tennessee, Missouri, kind of that area. It was kind of centered there. We moved quite a bit. Things moving pretty quick. It looks like we're over West Virginia, Virginia line now for our center. Let me get the temperature lines on here. We'll see how much how baroclinic this thing is, and we got pretty significant closure on the isobars around this low. We got that low to the north now. That was kind of off the chart yesterday, and then we have the plateau high that's kind of pushed to the southeast a little bit. And that's kind of weakened. I got a chart printed out. Let me see what my centers were. We were 1,026 on the center of that high. Now we're 1,018, so that one's starting to weaken. We're 999 on that low, and we were actually 997 yesterday when it was over just to the west. So that thing's filled a little bit, but 2 millibars. I mean, so not much. Still a pretty intense system. I mean, we got it's like 3, maybe even 4 closed isobars around that low, and then it's kind of pushing that trough off to the west, just over Texas. Maybe another low kind of trying to form up there. If you look at the advection, that temperature advection, you bring your fronts out and wrap it around that where that advection is, then we might have like a front starting to become stationary and a low starting to form off of that. So let's keep an eye on that for the next couple of days. See if this low actually forms right behind that one, that low, and then this thing shoots up to the north, and then this low takes over and creates another system. We'll see if that's going to happen. Maybe not with this weak high behind it. Usually you need a pretty good high pressure system to do that. This thing, it may just kind of sit there and dissipate out. This low, it should just continue to push to the northeast and then keep filling, but it's going to take a little while to fill that one. That's a pretty deep low for one over land, and especially this time of year. So 1,007 millibars to the low in the north. We definitely have some warm air advection around that low, some cold air advection, so we probably could put some fronts right out of that low also. Let me get my chart, my surface plots up here. We can get some wind directions. Read these plots and see what we got. How valid this chart really is. I mean, it's pretty good. That's a pretty intense low pressure system. We're going to go into the upper levels on that. We're going to break it down. We'll see what kind of support, how far up it goes into the upper levels as a closed low before it just becomes a open low or a trough. So you can see all your low ceilings right behind this low. So we got basically this thing was occluded yesterday, and then it's still occluded, and then wraparound moisture, and we just got these IFR conditions with the red, marginal VFR conditions with the blue, and that's dropping them ceilings and visibility down. Pretty significant right behind that low, just with all that wraparound moisture. This thing just kind of sitting there and just rotating, but like I said, from where it was yesterday, it's moved pretty significant distance to the east, so it's and it's filled a little bit, but it's holding its own. I mean, it's still pretty intense. Once you get over here too, off the east coast, this thing pushes over the water, and then you start getting this onshore flow like this, and these isobars as tight as they are, there's a 20 knot wind right there. You start getting that onshore flow, then you're just pumping that. You got your warm air advection, warm moist air pushing onshore right around Connecticut, Jersey area, and the ceilings are dropping. It's marginal VFR, broken, overcast, rain. You just get that. Basically, the warm air advection ahead of that warm front, you will get the stratiform clouds. It's more stable, and it will just continue to rain up in that area. So back where the cold front is, depending on dropping it down in that trough, wrap this thing around, depending on where we place that, looking at wind shifts and stuff, we that's where you'll get your cumuliform clouds and your convective activity, and then up into this low around that the occlusion is where you can get some heavy rain, lower visibilities, lower ceilings, which that's what we're getting right there. So let's put the computer generated fronts on here. That's probably going to be a little bit of messy, but let's get an idea where our fronts are. I could say like this one, we got a pretty good wind shift right here, one out of the west and then out of the southwest. I don't think that's bringing any fronts out there though. Let's see, we got 66 on the temperature. What's that? 56, 49, 59, 51. So I mean, maybe right through here we got a calm wind there, 56 there. I'm gonna probably bring that occluded front out. Get some notes over here for an occlusion. We got maybe that's like a I was trying to point toward like a warm occlusion yesterday. Little hard to tell. Maybe a cold occlusion if it wraps around. How far that occlusion comes out of that low. You're looking at warm air advection, definitely warm air advection in this area. So your occlusion is going to have to be probably back right here up in this thermal ridge. Bringing that occlusion right around here. Warm air advection, warm front out, cold front down, and then there's really no significant trough to bring that out of. Have a look at these temperatures at the south. We got 71, 72, 81, 50. What's that? 50. That's a dew point. 60. I can't tell what that is. 82 maybe. 61. I got to get a. Now the lines are just crossing right there. It's hard to tell what that one is. So we'll have to see where that cold front's dropping down, if it's actually wrapping around. Now here's a kind of a wind shift right there, so 62, 72, I mean it's a 10-degree difference. Probably bring that cold front right around here, I would think. But this thing's kind of, once it becomes occluded and it's mature, it's like that cold front's hard to decipher, because typically your cold front's just going to drop right back down, drop down into Florida, where the leading edge of that cold air advection. So you probably just put it right back down through there, instead of bringing it all the way over. Once you get out of these isobars, you really don't have any major advection, so you kind of got to stop that. But there's a 72. That's a 72. You're still in the warmer temperatures out west. This chart's kind of cluttered, so it's hard to read some of that data, but maybe just bringing that front down right around to the leading edge of this cold air advection right out of Louisiana. Winds are out of the south over here. We definitely got warm air advection, so with our warm air advection, we're going to have to bring that occlusion down into this ridge and then bring a warm air advection up out of that, off that triple point over to the east, and then that would be the leading edge of that warm air advection there, and then you have the warm sector behind that. Alright, so let's just go ahead and throw the fronts up here, see where we end up. We know that was occluded. That's pushing down. It's not really crossing into with that warm front. That warm front's just dropping south. I mean, I think that's wrong. I think what this needs to do is come out. That warm front needs to come out just to the south of that real strong gradient right there, that thermal gradient. The cold front dropped to the south, right down to even through south of Florida. So kind of, let's see, I don't think I really agree with that too much. I'd almost have to bring that right around here and just run with this wind barb right there because of that direction, and then your shift right there, and just bringing that right around that way. That's the way I would do it. Now this up here, this low pressure system to the north, we definitely seen that warm air advection, but you're dropping, I would bring this thing's just a mess. They dropped it right here out of that low. I would have dropped it out of this low right down where that thermal gradient is. You have that thermal ridge. There's the leading edge of that thermal gradient where your warm air advection is. Let me get a pin on this thing. Alright, so kind of agree with that triple point. We're close to that thermal ridge right there. I would bring that one. Man, that thing is huge. What's going on? Hold on just a second. Get rid of that. You're not able to see that anyway. Wow, that is crazy. Let's go. All right, let's get okay. Let me do a test on this pin. I don't know why that is so huge. Let me get this thing cleared out. There we go. I don't know. It was on the skinny part, but it was drawing huge. So, like I said, right from this triple point, I kind of agree with the triple point. I would bring that, but I'll bring this front back, even, you know, just because of that wind direction right there. Has to ride that direction in front of that frontal system, and then your shift is right there. So bring that back a little bit, and then you got your cold air advection. There's really not much going on right there. That'll almost go stationary. This, let's see, we definitely got cold air advection here. So right there, bring that front right around, kind of to that area, right through there, and then becoming stationary if you had to. This one up here, man, this thing's a mess. Let's go. I'm looking for here's a flow right there. I'm just looking for that easterly flow. There's a northwesterly flow. So your rotation is pretty much up in that area. Alright, so if your low is in that area, then I would bring that warm front based on these winds. We're pushing up, kind of pushing up there. We're pushing more, getting more easterly here. So bring your warm front right through that area. Right where the leading edge of that warm air is. Then you got that high pressure. I'm not going to go into that low. So I would have brought that a little bit further north. We got, since the cold front is going to come out of that, we need to almost have a closed isobar right there to have our cold air advection, bring our cold front out back into the trough. Let me go ahead and clear this out just for now. I would have brought that all the way back because we still have cold air advection there. There's our winds right there, pushing behind that cold front. So we're okay right there. Let's get into this. Let's get into this system right here, man. This thing is a closed low. And we got closed isobars all the way out on this thing. All right, so we are going to look at our low, kind of get our low center. We're right around West Virginia. I mean, we got a southerly wind there. I'd bring, let's go back. Let's get rid of this. Put our surface data only up here. We want to see some rotation. We got to have rotation in that deep low. Alright, here's our easterly flow. I'm going to have to get back over here again. And alright, here is the easterly flow right there. So then there's northerly from the north, from the south, west, kind of shifting right there. But right here's our rotation. I would say that is definitely where that low pressure center is. How come we can't see anything? I erased it. Never mind. Okay. Turn that back on. Probably bring that low a little bit to the north, just based on the wind directions. Alright. So, right over West Virginia, we would say the low pressure center is there. We have closed isobars above that. Now, we want to go to the 850, and we want to see where the next low pressure system is. How far does it stack back? Is it starting to become vertical? Is it going to just sit there? I don't think it's going to sit there. I think it's, our steering flow was pretty steep as far as that jet stream. We had a long wave trough, and I think we're pretty much that steering pattern is going to keep pushing this thing to the northeast. So I don't think there's any reason for it to stall out and just start filling. Sometimes right over the Great Lakes region, even in the Ohio Valley, you get a low pressure system, just kind of stall out, fills from the bottom up. Next thing you know, you got an upper level low, you got a bunch of minor shortwave troughs moving around that low, and then you just got on and off rain for like 3-4 days straight. So that does happen. I don't think this isn't the case of that. It's this low, pretty intense, and it's not looking like it's got any signs of giving up anytime soon. So this thing's gonna push off, push way to the north, go up into the low pressure graveyard, way up in the north. Let's get like I said, get the 850. Now we're going to pull up some pressure. We're gonna do a balanced height because this low was too intense for this surface computer system to analyze. So it's kind of extrapolating a bunch of troughs and ridges. So if we do a balanced height, then it gives us a little bit better look at what's going on. Takes them a little bit longer to analyze that too, because it's just way more accurate and it takes a lot more data processing. Okay, so just placing this over top of that, we got one big isobar right here that we can see. Here's our low. That's all in the surface pressure. And then I overlaid this. That's why it looks like a big pile of spaghetti. But we got all of our low ceilings behind that low, right over the 850. That's where a lot of our moisture is because of these ceilings. We got IFR, VFR conditions, marginal VFR conditions, so we got really low ceilings there. But our moisture, I guarantee, goes all the way up to at least to the 850 right here. And then we got one pretty good size isobar we're stacking back. If we look for our low pressure center behind that surface low, then we have to put the data on here to look for our wind change. I'm looking at surface data. Right now, all we have is pressure contours at 850 millibars, and we're just looking at where that closed low is. So if I get rid of this, let's go do that one more time on the 850. Do balanced height. Like I said, this takes a minute. I'm not going to do that on every chart. It just takes way too long. I'm going to do the balanced height because it gives us a more accurate reading. But I'm not going to do those overlays where I have to erase it and then do it a second time. We're just going to have to kind of start looking at. I'll tell you what we do. We could use our pen and then we can erase that. Not really erase it, just turn the program off. Leave that surface low on the marker. Go back to, and then go up to the 850. We can mark it with the marker, and then we can turn that program back on and see where the surface low was and see what kind of stack we got. Let's do that real quick. Now, I know it's going to take a little bit longer to do it this way, but let's give us a pretty good idea where our how much we're stacking, and you can see the stacking, and we can also place our surface front, place our upper front. With that intensive a system, we should have an upper front to the 850 at least, maybe even to the 700. So we want to get a good look at that too. So with the drawing program, we can put all that on one screen and then just turn it on at the end and see where we're at with our frontal stack, our frontal slope, and our low pressure, the stack of the low pressure toward the cold air. So go back to the surface. We're going to go surface pressure. Alright, we said this low was a little bit to the north, so we're going to go erase this. We're going to put our low right here. Okay, so we're going to go one more thing. Like I said, if we turn this off, that just disappears. It's still in that program, but it disappears. So when we pull it up at the end, we can see all of that. So if we go to the fronts, let's look at our fronts real quick. If we go... See, I don't have you turned on either to be able to look at this thing, which that's okay. Let's go. purple line for our occluded front. We said this front's going to kind of stretch back. I probably went a little further south on that. And then the warm front, I'm going to bring it out a little bit. So I'm drawing on the screen. You can't see it, but you'll see it here in just a minute. And then I'm just copying the surface right now. So let me get back to the 850. Let me go ahead and turn that on where you guys can see the drawings. Now, so we just ran an 850 contour height, and it just extrapolated the trough, a ridge, troughing. That it's not representing that low at all. It's just kind of averaging everything out and smoothing everything. So that's kind of a bad way to do it. We go to the balanced height, then we can start seeing those closed isobars. Because we know with the intensity of that low, that's a mature system that we're going to have a closed low at least at the 850. So let's see what something takes a little bit. Alright, so there's our closed isobar at the 850. We have one closed isobar, then we have a trough. We got ridging, and then that low pressure system that was to the north. So some temperature on here. That's just a little bit of a trough supporting that. Maybe a little bit of thermal ridging. High pressure. We still got the high pressure just north of the four corners, so that's kind of vertically stacked from the surface of the high. Let's get we'll put the station plots on this. Then we can see where our wind barbs are and where our rotation is. We'll find our high pressure center, so we can see it right there. We're just gonna go. Let's turn this on, and we see there's our surface low. Here is, I want to actually get rid of that. Go to the right color. We got a rotation right there, so we're going to be, I mean, we could almost close another isobar right around that low. So the computer didn't do that, so we could almost have two isobars on that. Now, the other thing would be the cold air, warmer air we got. If we went with, let's go blue, and we're going to actually start looking for 2 degrees, 10 degrees. It's a little bit hard to read. 9 degrees, 5 degrees. You can almost just put your upper front right back here. And that's a pretty, far slope right there. That surface front's actually right there. Like I said, I probably dropped it a little bit further south, but if I brought it back up here, now we have a stack, right there. That's a shallow slope. If we place our frontal system there on that cold front, like I said, this is a well-developed low. You want to catch these things back into the United States a little bit better, but with this slope being a shallow slope like that, then you should see most of your cloud cover and your precip will pretty much be right at and behind the front. So that's where most of it's going to be. As that cold front comes through, I'm messing this whole thing up now, so if I can clear any of that out. So, because I kind of want to keep my fronts right there with all that, without all that scribble. Okay, we can undo. Alright, so like I said, bring this one back kind of through Florida. Let's get my eraser. Straighten this up a little bit. I want to kind of keep it accurate. Alright, so we got a pretty shallow slope. We're just looking at the cold fronts. I'd say there is definitely an upper front there. Depiction of this upper front is the surface front is colored in solid on the frontal pointers. That indicates that's the surface front. Upper front, they're just left open. Okay, now we got the low pressure system stacking back toward this colder air. There's a center. There's a center. So we got a pretty good stack. And now let's go up to the 700 millibar. See, I'm going to go to a balanced height on that one. That's going to take just a second. Now I guess the other thing to look at for upper fronts too is like you're going to want to look for those significant wind shifts. You're going to look for the temperature drops mainly, and then dew points too. That would help to determine if you have an upper front or just a, closed low with a trough out of it or something like that. But as intense as this system is, and as close as that upper front was, so I think it's a shallow slope, but we're still definitely being a well-developed system. I would say we definitely got an upper front. Now we go one closed isobar at the 700, just like we did the 850. Pushed a little bit back toward the west, toward the colder air, and then once we get the data on here, I'm gonna get rid of that. I hit the Fahrenheit. I want to hit the that's why I hit the Celsius, just because that's what they use in the upper levels. And then do got some significant advection, so we'd almost have to see, kind of get an idea where, if we have an upper front here, or just call this troughing. But this is a closed low with a pretty deep trough. So I mean, let's get the station plots on here. Significant wind shifting, obviously around that low. -4, -4. Not much real temperature down here we do. So we're almost going. What we're doing right here is, let me get, I would say, since we have a southerly flow here, there's our easterly flow. Now kind of got a rotation right there. Now let's go back to the drawing board. Now kind of got a rotation, almost put our low stacking back right to here. Now it's starting to get a little bit further apart, looking at that center, and then bringing in any kind of colder air. What do we have here? Warmer temperatures are well to the south, -6, -4. So if we had another cold front, we're ignoring the occlusion on these, but I just go by with the cold front, the slope of that cold front, because I want to see where the weather is going to be associated with that front. Is it plowing the moisture, the warm moist air, and forcing it up, or is it just kind of sneaking under it and then slowly rising it up? That's a pretty fast moving system, because it went over to West Virginia. We were about right where that this 700 millibar low is right now. That was where the surface low was yesterday. So we moved a significant distance. It's moving fast, but it's still a shallow slope, and it's fast moving cold front, but typically shallow slopes are slow moving. But the way this thing is so wrapped up in itself, there's really no significant like high pressure systems doming up, and that's the slope is your cold air. you got one big cold bubble on the surface, and then the slope of that cold bubble is what the leading edge of this cold front is. So if we had to place another front, it almost would be just vertical over that one. So that tells me this thing starting to spread apart like this. Typically what they do, either dissipate in the upper levels, but they'll fill from the bottom up usually, so they'll kind of become more vertically stacked. This thing's still spread out pretty good, so I'm counting on this thing just to keep running and keep pushing to the north. So there's our 700. This one 850, and then this is the surface. Okay, so I would almost go either no front or just go vertical right over top of that 850 front and this thing. But you still got, like I said, significant moisture advection all through here. I should have left that blue. Significant moisture advection all through here. So this system still creating the weather, creating the ceilings. We got moisture. We're saturated. Anything that's black is has a dew point depression of 5 or less, and the dew point depression is the difference between the temperature and the dew point. So we're -2 of a dew point on that station, and let me not mark on that too much. That means we have reached saturation, and that's why the station is colored in black. See if I can get this thing to undo enough times. Okay. Alright, let's get back to definitely got significant moisture all the way up in that level. And close that off for a second, and we'll go to the 500. I'm going to do a balance height on that, and that'll just take a minute. We'll run some other algorithms. I got some scripting for this program, so we can run those charts and see what our lapse rates are, stability, and I got one that's kind of an area, it shows areas of possible severe weather, stuff like that, but we're kind of getting to the end of that season. Now this one's pretty significant too. We're closing off 2 isobars with this one. Get our temperature lines on here. See, that's a pretty deep trough right there at the 500 millibar. Definitely some advection, strong advection, and then get our plots. And we got all the black you see is still significant moisture. So we can almost pretty much close this one off too. Now right here we're looking at, let's get the program turned back on. So we got pretty much right there the same thing. We're almost, if you look at the rotation, we're pretty much a vertical with this low. So that's also the 500. Now we're becoming vertical. These are stacked back toward the colder air, becoming vertical. Now that shows me that this system, it's a mature system. We know that. Pretty deep low, starting to fill, and then become more vertical in the upper levels, and not having it's just basically losing its, starting to wind down a little bit. So we're gonna get, we need to go look at the jet stream. That'll be the next chart, 300 up, and then we can see where our jet goes through. If we look at possibly just right here, the 300 is probably not going to look much different than this, but with the jet stream actually going to be right behind that surface front. Get rid of that real quick. So if we go jet stream right behind the surface front, see the stronger, here's your stronger winds right there, and then pushing back up. So that's where the jet stream is going to be. There's your jet support for that front, and then you're going to come out this way. So with that jet. Alright, so that gives you that jet support, and it gives you the support for that surface low to keep sucking that mass out of that system, to keep that low going. Get rid of these reds. Okay. Like I said, the low pressure 500 millibar is right there. And erase that. We're not erasing it. We're just going to shut that off for a minute. And then we go. Let's run two charts while we're at the 5. Or run one chart while we're at the 500 real quick. Let's run the vorticity. Get rid of this. Alright, run a 500 millibar vorticity chart. This just shows where our upper level divergence is. Positive vorticity, anything orange, is upper level divergence. So there's our low pressure system, pushing back, and then there's positive vorticity. We got upper level divergence at 500 millibars right there. So we are pretty close to that low. There's the upper level divergence, the jet with the jet support sucking the mass out of that. So we have upward vertical motion from this low, and then with that PVA, that could be, see, if you get this frontal system pushed back and then you get this positive vorticity advection over that dissipating cold front, one undergoing frontalysis or becoming stationary, then you can get another low pressure system pop up over top of that. But right there we have all the support we need for this intense system. Let me get you back to where you can see that. Okay, as I mentioned, that PVA supporting this low, jet support, anything orange is positive vorticity advection, indication of upward vertical motion and rotation. So we know we got a pretty intense low pressure system and rotation with that low. Now these thickness lines for the 500 millibar contours, that's off. We didn't do this chart doesn't automatically do a balanced height, so we've seen on the 500 we were closed. That's our 500 millibar low right there. So we're gonna get rid of some of this, so we keep our chart kind of clean, and then we can go erase that, and then we can go back. We can go up to the 300, and then we can run a jet stream, and we'll run the contours, and that will actually give us show us where the low pressure system is at 300 millibars, and see if we have a closed low there. If you get a closed low from the surface all the way to 300 millibars, you got a pretty intense system. All right, so we're going to do our height, our pressure balanced height on that, and that should pretty much line up kind of with that jet right there when there's jet maximums. So we got definite support for that low. That low's right where that what's a little bit south of where that jet max is over Illinois, Iowa, and Missouri. And then we'll see where our closed isobar is here and see if we're still staying vertical in the upper level. So on that for the pressure. Alright, definitely got some intensity going on here. Still staying pretty vertical on that low. Let's go to let's get our isotherms on here and our station plots, and then we can go here to then turn these back on. So right there we're still vertical on that 300, closed, pretty intense. Let's see what we got going on. It's hard to see that red. There's red dashed lines. There's our isotherms, one there. See, where's that one going? Looks like it's a little pocket right there. Okay, this one's going through here. Up that way. This one's going down here. So we got a little bit of a cold air or warm air advection there. We have really a weak, nothing. There's no isotherms there. We got that little pocket, so we don't have any major warm air advection or cold air advection over the behind that low at this. And we're still vertically stacked. So now we are becoming vertically stacked. The upper level system is catching up with the surface system, and then it's becoming vertically stacked. That's why we're starting to fill. Well, there's only 2 millibars, so it wasn't a significant fill on that system. Nothing going to kill it overnight. So let's get rid of some of these red. Man, it was a lot of drawing. Okay, so there's our stack back to the upper levels. We got even got the 300 right here. So like I said, we're vertically stacked right there. We just only got three actual closed lows stacking back. Then we're just, the last 3 are just going vertical. So let's look at a couple other charts. We pulled that vorticity. We know basically that vorticity was just to the north right where that jet max is. So we have upper level divergence there. What you can look at on this to tell that is, and this probably right here would be a good indicator of filling that low. We got, what is that, about 60 knots out, and then 45 knots out of there. So this wind's catching up with this. You got speed convergence right there. That would be an indicator of pushing down on the surface, converging. So upper level convergence would weaken that low. We have 70 to 65, a little bit of speed convergence there. We got actually these wind directions kind of pushing together right through here. That's a directional convergence. So we're starting to get some convergence in that area right above that low, and that gives that downward push to start filling that low also. So we only had, like I said, 2 millibars on the surface, but that's going to be probably a little more significant tomorrow. We'll get a look at that chart tomorrow and the surface chart, and we'll do a comparison and see where we're at there. So I'm going to go ahead and get rid of all that ink. And here's our low pressure system off the, we got ridging and low pressure system off the East Coast. That's what that caused all that weather over Connecticut, Jersey area, New York. So we got high pressure. We got a pretty significant ridge over there, over them 4 corners. That's still supporting that high on the surface. Really nothing in the upper levels for that low that was at the surface. That's just kind of pushing down. But this is the main system we just keep an eye on right there. And then that high pressure. The high pressure ain't going to really do anything. It's kind of like a plateau high, and it kind of moved to the east a little bit, but sitting just north of the 4 corners, supported by this ridge. It's not like a major intense cold air moving through the surface there, causing Texas or anything going to a cold freeze or frost or anything like that. So that'll be a polar outbreak. It drops down out polar vortex. We get a high pressure system drop out of that with that cold air, and then that pushes all the way down Texas. We may see that here. We do got I think about 2 weeks out, we had a pretty significant polar outbreak coming, if the models hold true on that. And these patterns, the way I'm seeing them, the way these high pressure systems are pushing through, and the way this low pressures, how intense they are, I think we're looking at some significant systems pushing through this year. It just depends on where they start up, where these low pressure systems start up over the mountain ranges, Colorado low. If they actually start over Texas, or if we get one that starts over the Gulf, be able to pick up that moisture and then push to the northeast. That would be a significant system we would see there. And that can happen with those polar vortexes pushing through. They could just stir up these lows and then just launch them to the northeast. And after picking up moisture off the Gulf, that is where we can get some intense rainfall and snowfall for the winter times. All right, let's get out of here. Let's go back to the surface, and then we're going to actually run some charts. First thing we're going to do is, let's go with possible severe weather chart. We got two of those. One runs a little bit more intense algorithm just to paint the picture a little bit harder for you. This one's a weak one, so this thing might not show too much for severe weather. Like I said, we're getting out of that season anyway, so right there, slight chances off the coast, and then off the Baja California there. So we're not the Baja Peninsula. We're not nothing significant. Let's go back to. We'll go with the more intense one. It will have some brighter colors on it and stuff like that, but I don't see any major significant change on that. I mean, some areas right there, maybe for some thunderstorms, stuff like that, but nothing severe. Now this up here, let me get to. We're at the surface. Let's go ahead and pull the. Let's wait till this finishes. We know we got that low pressure system. You have a lot of convection, some water spouts off the coast, even down there, and then. See what's going up. Well, that's that low pressure system up to the north. We had that weak cold front pushing through. So anything there could be severe if it got that to that point. But I don't think. I think the temperatures are a little bit too cold for that. The dew point's way too low. So I'm gonna throw that surface analysis over top of this. Alright, come on, Speedy. Taking its time. I think I hit the wrong button, that's why. I hit the station plots. And I'm set at 99% of the plots across the United States, so it just wants to take a minute to load all those. This is going to go south here in a minute. Not too bad. It's just going to be a screen that has so many station plots on it you won't be able to tell. I've mentioned that in a few videos, that hey, if I set this at 100%, here's what's going to happen. This is what's going to happen. There we go. Alright, so you can see where your that low pressure is, and all your lower ceilings are back behind that low. And then you go marginal VFR, and then all the black is pretty much that's just so many wind barbs that it's just so cluttered, it's ridiculous. So let's get out of that. Alright, I had that severe chart. I was looking up in Montana what's going on up there. Let's get this back on the surface here. I'll make sure I'm on the surface. And then there's that low pressure system right there. We got that cold front that was pushing through. That's what's causing that area of instability. Let's throw our let's get rid of these. We're gonna throw the isotherms on there. And then we're gonna back that surface plot off. And we're down to 85%. So let's see what happens here. That just takes a minute to plot that. So all right, dew point's 39, 67 to 30. Temperature dew point's 55, 35. I mean, we got pretty low dew point. Like I said, it's actually snowing up here in Canada. So like I said, it's that chart's used for possible severe weather, but this could be, possibly get some heavier snow right in this area. But we'd have to see what happens. We got snow there. How much moisture is available in that system? That's what really needs to be looked at. Go look at the moisture content and the dew points, and try to get an idea of what we can get for snowfall. Snowfall is a little hard to predict more than just a few days out. Some models catch it 3 to 5 days out, but you got to monitor those models every time they update to track that system all the way through to make sure they're holding true, because they tend to change really quickly. So we're back here at the surface. We said low ceilings north of the low. We know that low stacked back, and then it just went vertical. 998 millibars. And there's that high pressure system over the Four Corners. That was kind of pushed back north of the Four Corners, just south of Wyoming right there. Which we don't really worry about that as far as stack on a high pressure. I mean, high pressure is, pretty much clearing 7 unless you got some kind of upper level trough, upper level low above that high, because you'll have that cold air mass on the surface and upper level low above that, and then creating that precip falling through that colder air and causing snow, freezing rain, stuff like that, because that air mass is so cold on the surface. If you're 600 to 1200 feet, you're going to have mixed precipitation. If you're below 600 feet on the freezing level, you're going to have snow. If you're above 1200 feet on the freezing level, you're just going to have rain. So it takes less than 1200 feet for any other type of precipitation to form. Alright, I wanted to run another chart. Let's go back. I know it's getting a little bit long on this video, but we are going to run some script on. Let's do our lapse rate. Let's see what our lapse rates are around that low pressure system. If it's any steep lap rates behind that front, I don't expect it to be, just because where those fronts were placed, there's not. It was a slope. That slope was shallow and then becoming vertically stacked. So right there where that low is, we have a lapse rate of 5. So that's weak. We want 6 as standard, and then anything 7 to 8 is where you start getting pretty intense. That's why, like that one chart was showing down here over the Baja Peninsula, where possible severe weather down there. So that was, the lapse rates are getting a little bit steeper down there. So I'm not too that low pressure system, like I said, the upper level low on that system is starting to catch up with the surface low, and then I expect it to still push to the northeast, and then all that could become vertically stacked, and then just start filling from the bottom up, and then go out to the graveyard and wander around in Canada for a while, and then just dissipate. So alright, what else? We can do some low level shear. See what kind of wind shear we have with that. So we probably should see some with that low as intense as it is all the way up. So we got some significant low level shear all the way at that surface, with that, like I said, as intense as that thing is. I mean, this is a pretty significant to the northeast or northwest too. So, and then pushing back where that, just back toward that high. We know we got a pretty good strong pressure gradient going on right here. So low level wind shear will be pretty significant. So that does make sense. And then we go to mid shear. We're not gonna keep too much longer. I'll see if I got a stability chart we can look at. The lapse rates is one of them. If we got another stability chart, we'll look at that next, and then we'll pretty much call it. So mid-level shear, we got some mid-level shear all the way across the country. So, well, we know that the jet stream, I mean, we start getting up to the upper levels, the lower part of that jet stream, you're going to have some wind shear. And we've seen the convergence in the upper levels with just speed convergence, and then we've seen some directional convergence also. So that kind of matches up. And then where our jet maxes are, we know that jet max was actually over Illinois, right about Illinois and stuff. So we're getting we're kind of in that area with the mid-level shear. So that's making sense with the jet stream too. All right, one more chart and we will call it. Let's go see what I got. Let me go up a folder. Let's see. Instability index. Let's see what this one does. This should show areas of instability, which we know that low pressure is pretty unstable. So let's see how this thing picks that up. Nothing. This is a stability indices, basically like off that SCU-T chart, and we're just not seeing it with that system. That is crazy. Which we don't expect severe weather with that system right now. We're just looking at, it's a possible thunderstorm still around that low, but not anything majorly severe. So let's go And I said that was the last chart, but we're gonna see if we can get something a little bit better than that. We got a fog stability, so I don't know if we'll get anything on this. We got surface winds too strong. We're not gonna see any fog, and that's gonna be mainly our problem. But we got a chart that will actually show areas where fog should form. So we'll see what happens. No fog. Done. Alright, so maybe it's not finished. Still alright, there we go. Well to the north. Just taking a little bit longer. Alright, so really well to the north would be any significant fog. We'll skim through this list one more time. And I had some other instability indices that we can. Now I got one more in here somewhere. Here's a VT index, TT index, good total totals index. That was off the SCOOT. That will actually uses this upper air data to calculate that, and then determine if there's possibilities of severe weather at that too. See how well this one works. Which, like I said, I don't really expect a whole lot with that low pressure system. I mean, you can have that, but some areas of thunderstorms, always a possibility of severe. I mean, they don't forecast severe till a couple of days out or something. But the Storm Prediction Center, and then it's like slight chances and stuff like that. So up over the Great Lakes, looks like there's a possibility, and then we've seen that over Montana, but we knew that was more of a colder system, so we really don't have to worry about too much about major severe thunderstorms in Montana. Alright, so that's it for that chart. We can see the upper level winds. I don't know which winds we're plotting there. It's hard to tell. It looks like 500 millibar. So we had those 90 knot winds, 85 knot winds, and then you can see the troughing and then that rotation. So that was where that low pressure, that's where that low pressure center is, around about 500 millibars. So alright, so I'm going to end this one here. This is just kind of breaking down that system a little bit. We looked at the slope of that front, where the moisture was in the upper levels. We can see that with the black coverage. I do have another script that will show it as in green. Anything typically it's above 60% humidity, it will kind of color green. That gets a little off sometimes because the data, actually some of those upper level temperatures and dew points, they update on the moisture side of it, but they don't update. They only launch these balloons every 12 hours to get this data, so that sometimes it just doesn't line up. So we got that pretty intense low. Let's keep an eye on it, see how far it pushes to the northeast tomorrow, and then how far it travels. I mean, it traveled pretty good distance in one day. We'll see where it travels next, and then we'll get maybe come back tomorrow and see what we got for a how this thing filled. 999 millibars right now, and that thing was at 997. So we went 2 millibars. Is what we filled in one day. So we'll keep track of that for tomorrow also. So alright, thanks for watching. I know this was a little bit long video. You can learn some of those tips and tricks in the upper levels. We can get deeper into that stuff too, like steering flows, how to tell how fast the system's moving from the 700 millibar winds and the 500 millibar winds, and do those calculations, and then we can keep on going. So if you like these videos, give me a thumbs up, subscribe to the channel, give me some support, and I'll keep them coming. Until then, get your head in the clouds.